Hi everyone, I am Dr.Kiran Raavi, working as an assistant professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad, India. So today we are going to discuss metal oxide semiconductor. Let us see the overview. So we'll start with the introduction, MOSFET and characteristics of MOSFET, comparisons and conclude with summary. So this we have already discussed in the previous class. So FET is a unipolar device depending solely on either electron or hole. So p channel conduction. So that is p channel means so when the principle of operation of MOSFET depends on particularly holes, then we can say it is p channel conduction. And then the charges present in the FET establish an electric field which controls the conduction of path of the output circuit without the need of direct contact between the controlling and controlled parameters. So today we are going to discuss these are the types of MOSFETs: N channel and P channel enhancement mode MOSFET, N channel and P channel depletion mode MOSFET. So operation of N channel depletion mode MOSFET. So this is the setup for the N channel. So for N channel we have to consider P substrate. So on P substrate we have to diffuse this N type N-doped material. So through this N-doped materials, so there are small holes, and through these holes we can form gate. So coming to the operation, gate is shorted, that is first case when VGS is equal to gate is shorted means gate to source voltage is 0 and VDD is applied. So we have output VDD biasing voltage we have applied, and attraction of the free electrons of the N channel for the positive voltage at the drain. So this is a drain because it is positively connected and this is positive. So obviously from this N channel N type material is connected. So an attraction of free electrons of the N channel. So this is N channel for the positive voltage of the drain. So these electrons are attracted towards the positive terminal of the biasing voltage VDD. So that the result is a current similar to that of flowing in the channel of the ZFET. So the characteristics, if you compare the characteristics of FET and ZFET, MOSFET, almost similar. So you can observe the output characteristics. It is the graph drawn between VDS and then output current ID. So as we increase the VGS value, so initially VGS is equals to 0 we consider. So when VGS is equals to 0, the current reaches its saturation level. That means the depletion region takes place. The depletion region touch here. So the depletion region will be increased. So in such case, there is a increase in the drain current reaches some saturation. So that saturation current is called IDSS. So if you further decrease, what happens? The resistance increases and the current decreases. So if you further increase the negative voltage, gate to source voltage, that is VGS is equal to -1, that means we are decreasing the gate to source voltage. Increasing negative value means decreasing the gate to source voltage. So when you decrease the gate to source voltage, so correspondingly the resistance of the MOSFET increases. So correspondingly current decreases. So resistance increases means what? Current decreases. So this is the graph for the output characteristics. As VDS, if you keep on increasing VDS, so there is no increase in the current, whereas current reaches saturation. So after that pinch off voltage, if you increases, so the drain current is constant. So it reaches already saturation level, but it does not falls to the 0. So similarly, so next case there are two conditions: depletion mode and enhancement mode. This is depletion region and this is the enhancement mode operation. So coming to the second case, when gate is shorted, when gate is less than 0 volts, VDD is applied. This is wrong. So gate, we are giving some negative voltage VGS less than 0. So we are increasing the negative voltage, or we decrease the gate to source voltage. So VDS is applied. So an attraction of the free electrons of the N channel for the positive voltage of the drain. The result is a current similar to that flowing in the channel of the JFET. So if you recollect the channel of the JFET, see here. So let us say N channel JFET. So either side we have to diffuse this P side, P type material. So heavily doped P type material, and this forms your drain, and this is your source, and this forms your gate. Okay. So here outside we are giving this one, positive, positive. So electrons will move from emitter to source to drain. Okay, so emitter drain current will flow from drain to source. So in this case, when you increase this value, negative value, when you decrease gate to source voltage, or we increase negative voltage between gate and source, so obviously the reverse bias condition takes place here. The reverse bias condition increases, so the depletion width also increases. So when depletion width at a particular voltage of VDS, both depletion regions touch each other. In such case, there is a decrease in the drain current because resistance of the FET increases. So the same way here also you have characteristics like this. So based on the magnitude of the negative bias established by VGS, a level of recombination between electrons and holes will occur, reducing the number of free electrons in N channel available for the conduction here. See here, this is N type, electrons repelled by negative potential at gate because it is N channel. N channel means what? N type material is there. N type material means electrons are the majority charge carriers here. So these electrons are attracted towards this P type material. Okay, and there is a recombination takes place. The more negative the bias, higher is the rate of recombination. So if you further increase, so there is a recombination. Recombination means less chance for the charge carriers to move from one side to another side. So that reduces the current conduction. So the application of positive gate to source voltage has enhanced the level of free carriers in the channel. So this is another. So if you apply additional positive gate to source voltage, then that voltage has enhanced the level of carriers in the channel. So now N channel enhancement mode MOSFET. So a slab of P type material is formed from a silicon base and is again referred to as substrate. So here the substrate is there. So here, and then the source and drain terminals are again connected through metallic contacts to N-doped regions. The absence of channel between two N-doped regions, so will be the enhancement. So here, if you observe here, there is no channel here. So the SiO2 layer is still present to isolate the gate metallic platform from the region between the drain and source. So the silicon layer, SiO2 layer will isolate these two. What a metallic platform, region between drain and source. So there is a region between drain and source. So this channel may enter. So in such case, so this SiO2 layer acts as an insulating material between these two, drain and source. So in this case, enhancement mode. So we have, if VGS set to 0 volts and voltage is applied between drain and source, then the device. See here. So we are giving, this is a setup for the enhancement mode MOSFET. So in enhancement mode MOSFET, what happened? If VGS is at a 0 degrees initial, that means gate current is 0 volts and a voltage applied between drain and source. So VDS is applying and Ig equals to 0. So the source and drain terminals are again connected through metallic contacts. So here source and drain are connected through metallic contacts here between two N-doped. So these are the N-doped. This is one side and this another side. So these two are between. So the absence of channel between two N-doped regions. So there is a absence of channel between two n-doped layers. So previously in depletion mode, so there are n channel is developed between this drain and source. So here it is the absence between two n-doped regions. Here the SiO2 layer is still present to isolate gate metallic platform from region between drain and source. Again SiO2 layer acts as a insulator here. So now it is not sufficient to have a large accumulation of carriers, that is electrons, because it is channel is n type. So electrons are the accumulation of these carriers at the drain and source due to n-doped regions. If the path fails to exist between the two, so this is another important point here. It is not sufficient to have a large accumulation carriers at the drain and source due to n-type n-doped regions. So if a path fails to exist between these two regions, so with VDS some positive voltage, VGS is at 0 volts and the terminal SS directly connected to the source. So this terminal SS is directly connected to the source here by using, but VGS is equals to 0 here and some voltage is given between drain and source. So there are two reverse bias PN junctions between n-doped regions and P substrate to oppose any significant flow between the drain and source. So here there are development of two reverse bias conditions, PN junctions between n-doped regions. So these are the n-doped regions. So there are two reverse bias conditions occurred, and which opposes the further flow of the carriers between drain and source. So now next case in enhancement mode, if VGS is greater than 0 volts, so we are increasing VGS value. So gate to source voltage increases greater than 0 volts. The positive terminal at the gate will pressure the holes in the P substrate along the edge of the SiO2 layer to leave the area and enter in deeper regions of the P substrate. See here, this is the P substrate and these are the electrons. So both are opposite. So usually both attract each other. So here what happened when VGS is greater than 0. So here gate to source voltage is more positive here. So more positive means in the positive potential at the gate will pressure holes in the P substrate along the edge of the SiO2 to leave the area, because they repel these gate positive voltage repels these holes from P side. So both are positive means repel. So it pushes towards the P substrate. So that depends. The depletion region near the SiO2 insulating layer avoid the holes. So therefore there is a decrease in the holes near the depletion region, and the SiO2 layer and its insulating qualities will prevent the negative carriers from being absorbed at the gate terminal. So there is no carriers negative prevent. So what happened here, the SiO2 layer and its insulating qualities will prevent negative carriers from being absorbed at the gate terminal. So the level of VGS that results in the significant increase in drain current is called threshold voltage and is given by symbol Vt, V suffix T. Since the channel is non-existent with VGS greater than 0 and enhanced by the application of positive gate to source voltage, this type of MOSFET is called enhancement type MOSFET. So by addition of gate to source voltage, so there is a chance of positive gate to source voltage. So we have the channel is established when VGS is equal to 0 and enhanced by the application of positive gate to source voltage, then this type of MOSFET is called enhancement type MOSFET. Now coming to the characteristics of this enhancement type MOSFET. So we have, if VGS greater than 0, positive voltage at the gate will pressure the holes in P substrate along the edge of the SiO2 layer to leave the area and enter into the deeper regions like this here. So any further increase in VDS, drain to source voltage, at the fixed value of VGS will not affect the saturation level ID until breakdown conditions are encountered. So here up to breakdown voltages encountered, so there is a constant voltage. So there is a linear relation between output voltage VDS and output current ID. So here at a particular voltage, for example this one, this is, we can say, saturation level of drain to source. So drain to source voltage is saturated at this point. So from this point of voltage, the output current, drain current will be constant, and also if you further increase, the voltage decreases. So the saturation occurs for lower values of VDS. So that is about the characteristics of second case. So coming to the P channel, so construction. So this is almost similar to the N channel JFET construction. So only thing is the polarities must be reversed. So here you have characteristics. So if VGS is greater than 0, the positive potential at the gate will be the construction will be the, so if VGS increases, so for VGS increases here, so what happens? Negatively. Increases means what? Negative case, we have decreased, right? So therefore we can say the at a particular voltage, again after getting saturation, so they of VDS or gate to source voltage, so we can say the drain current will be constant, or it reaches saturation level. So similarly transfer characteristics. So from this we can get the transfer characteristics. If you see that these are the transfer characteristics and these are the output drain characteristics. So this is about P channel depletion mode MOSFET. So this concludes MOSFET operation. So we have discussed these starting with the introduction: MOSFET, N channel depletion mode, N channel enhancement mode, and P channel depletion mode, P channel enhancement mode, and probably next topic will be special purpose diodes, that is under unit 5. Thank you.